So let's look at how to do some calculations with the normal model. So as you saw in the normal distribution overview, the formula is kind of messy and it's really actually very difficult to work with without a calculator. So the way we're going to do it for this class is using this program called GeoGebra. So here I've taken some problems from the WebWorks set normal area for arbitrary z, just to give you an idea. So if you want to follow along with your WebWorks set with different numbers, you can at least get a few of these filled in right now. So number one said the combined math and verbal score for students taking a national standardized examination for college admission is normally distributed with a mean of 1180 and a standard deviation of 220. If a college requires a minimum score of 1075 for admission, what percentage of students do not satisfy that requirement? So you need to go to GeoGebra to do the calculation. Any calculation with a normal model, you just can't do it on paper or anything like that. So over here in this window, I've gone to geogebra.org. I think it's a combination of geology and zebras, but I could be off on that. But if you go there, then just click on probability. That will bring up, there we go. Okay, so sometimes this program does weird stuff, so just kind of be aware of that. But here it's drawn a normal curve. There's a drop down here. If you take stats 2, you go through a few more of these. We'll go through another one in this class too, but just be aware now. It defaults to normal, so just stick with that. You don't need to mess with this button. What you do need to mess with is everything else here. You can enter the mean and the standard deviation. In this problem, the mean is 1180, and the standard deviation is, here's it being weird again and lagging, but okay. The standard deviation is 220. So a college requires a minimum score of 1075 for admission, so that is somewhere over here. What percentage of students do not satisfy that requirement? So what it wants us to find is the percent of students who get below a 1075. Because if they get below that, they do not satisfy the requirement. So just click on the lower tail and then type in 1075. And then you got to click elsewhere, press enter or something. It doesn't update automatically. But then you get this 31.66% or 0.3166 would be my answer to that. And hopefully when I type that into GeoGebra, it works. If it doesn't, either GeoGebra hasn't updated or just double check your numbers. Number 2, the shelf life of batteries produced by one major company, blah, blah, blah. Basically, you look at the picture, calculate the shaded area under the curve. Okay, the shaded area is everything not from 3.4 to 3.5. Here's the relevant information. The mean is 3.6. The standard deviation is 0.1. So type those in over here. Again, that's mu, like the Pokemon Mew, or the sound a cat makes, and that is sigma, lowercase sigma. So the shaded area, we want everything that's not between 3.4 to 3.5. So click the between button here and go 3.4 to 3.5. And that'll tell us that's 0.1359. So if we write this out, and 3.5 is 0.1359, and the total area is 1 or 100%. So the shaded area is 1 minus 0.1359, which I believe equals 0.8641, which was what I would type in GeoGebra. So there's some questions like that. We just have to know the total area is 1. GeoGebra can give you the between, so you just subtract that amount from 1 to get whatever's left over. Number 5A says find the area under the standard normal curve between negative 2.13, 1.86. So here again, standard normal curve means set this up with a mean of 0, standard deviation of 1. And then between negative 2.13 and 1.86, and I would get 0.952 is the answer I would enter into GeoGebra. So you might notice in GeoGebra, here are all your x values here, whether you're doing upper tail or lower tail or between. All the x values go in this probability of x less than whatever in the parentheses. And over here you get your area or your probability or your percent. It's called different things depending on the problem. But we can go the other way too. Number 11 wants us to find the z-score. So again, 0 mean, standard deviation 1, from a standard normal distribution that satisfies each of the following statements. And part A says the point Z with 14.01% of the observations falling below it. So below it is a lower tail. And the 14.01% now is something you would enter in this box, because that's the percentage box, and it wants you to find the Z-score. So it doesn't say Z here, it says X. It's not the best program. But you can see here, 14.01% is the lower tail area that corresponds to negative 1.0799. You might round that to negative 1.08 for web work, but it usually doesn't matter too much. So that's all of them kind of work that way. You just kind of translate the problem into upper tail area, lower tail area, what are the mean and standard deviation, and then what number do I enter in which box. Sometimes they try to trick it a little bit. They'll say, what is the first quartile score on this exam? Well, what is the first quartile? Well, Q1 is the 25th percentile, so 0.25 area is below it. So with that in mind, you have a mean of 526 and a standard deviation of 38. So you want the lower tail area that has area 0.25 below it, and you get 500.369 right here. The score is 500.369. Now watch the wording, because sometimes web work wants you to round to like the nearest whole number or something. The last one here is number 17, but I actually think I'm just going to delete that question because let's just call it good with that.